Hey guys, so today we're going to be doing a video on angles and finding unknown angles within shapes such as triangles or quadrilaterals. There is a bit of prior knowledge that is required before we go through this, and that would be just some basic understanding of angles, including acute, obtuse, right angles, etc. So let's jump straight through into it. So let's start with the triangle. When we have a triangle is made up of three angles. Each point will have an angle inside it. So as you can see in the triangle here, we have angle Y, angle Z, and angle X. Three angles inside any triangle. And the rule with angles within a triangle is they always add up to 180. So X plus Y plus Z must always equal 180. Now the rule will differ slightly when we go into equilateral triangles or isosceles triangles, but we'll get into that in another video. Within quadrilaterals, which is any four-sided shape, so a quadrilateral will include a rectangle, a square, a rhombus, a parallelogram, a kite. All of these four-sided shapes, so here we have a trapezium, will always have four angles. So here we have A, B, C, D. And the rule with a quadrilateral is that all four angles always must add up to 360 degrees. Let's go on to some other angle rules. So here we're discussing straight lines. Straight lines always add up to 180. Now a straight line can have as many angles as we want, but we'll always start at a point. And you can see that point there in between X and Y. So X plus Y will always equal 180. Right angle triangles, which are shown using that little box in the corner there, or those two lines, they always add up to 90 degrees. We also call right angles or angles that make up right angles complementary angles, and straight line angles supplementary angles. A reflex or a revolution or angles at a point always add up to 360, and vertically opposite angles are always the same. So here we can see that X and Y are vertically opposite. So if X was 20, Y would be 20. And if X was 100, Y would be 100. So vertically opposite angles are always the same. Let's move on to a question. Now this question, although it looks quite difficult, is not that difficult if you know where to start. So we're basically going to look at here, okay, where can we start? Where can we find something that possibly would help us? So here we can see, okay, we have 45. And we have A, which is vertically opposite that angle. And as we stated before, that vertically opposite angles are the same. So we can say A is 45 degrees. Write that here, 45 degrees. And we write that it is vertically opposite. And that's why you always should be giving a reason why the angle is what it is. Let's keep moving on. Okay, so we have 35 and D, another vertically opposite angle. So we know that D must equal 35 degrees as well. So 35 degrees, and we go down to D and we write 35 degrees because it is vertically opposite. Let's keep moving on. What else can we see here that we could possibly figure out? Okay, so let's look at this triangle right at the end. This triangle here. And if we look at this triangle here, we can see that it has two lines on either side, indicating that both of those sides are equal in length. So this is a particular type of triangle, and we call this triangle an isosceles triangle. Now, an isosceles triangle has two main features. The first feature is that the isosceles triangle has equal sides on two of its sides, and the second feature is that the bottom two angles will be equal in length. Now, we already know that that whole triangle has to add up to 180 degrees. And we already have 55 degrees there. So we can do 180 minus 55 and we have 125 degrees. Now, we can look at this as like, okay, we need to split that 125 equally amongst F and E. You can think of it that you have $125 and you have two kids and you need to split that $125 between F and E, the two kids. So if we do 125 divided by 2, we get 62.5. That shows us that both F and E are 62.5 degrees each. So we can write down here in F and E, 62.5 degrees. And the reason I'm going to give is an isosceles triangle. 62.5 degrees. And again, isosceles triangle. All right, let's move along. Let's see what else we can figure out here. Okay, if I zoom into this section here, that B in 110, what kind of angle is that? That's a straight angle. And we know that all straight angles have to add up to 180 degrees. So if we already have 110 degrees there, how much more do we need to make 180? We need another 70. So I can write 70 there for B, because that is a straight angle there. So we can label B as 70 degrees because it's straight. Now obviously you should write the whole reason. I'm just doing it in short form here so you understand what's happening. All right, let's move on. What else can we figure out? Okay, so now that we've got that 70, we have a triangle here. That's ABC. And we know all triangles have to add up to 180 degrees. So if I already have 45 and 70, I can do 180 minus 45 minus 70, and the remainder that I need is 65 degrees. I need another 65 degrees to make that a triangle that adds up to 180. So C equals 65 degrees because it is a triangle. Now, what else do we have? What other letters do we have here? We have H and G. Now, I'm going to do H and G differently here. We can use the parallel lines if we really wanted to, but I'm going to do it in a totally different way. There are a number of ways you can figure out those two, but I'm going to do it differently. So if I zoom in here, I know that those three angles there equal a straight line with the vertice of it being there, the points being there. So F, 35 and G have to add up to 180 because that's a straight line. So let's zoom out again and see, okay, that's a straight line there. What do I already have? I have 62.5 and I have 35. So G must be whatever's left over for 180. So we have 180 minus 35 minus 62.5. I need another 82.5 to make G. 82.5 degrees. Don't forget your degree symbol. 82.5. And that's because it is a straight line. Now, one more angle left, which is H. Now, if I look at H, I have this shape here, which is a four-sided shape, which we can also call a quadrilateral. And as we said before, all quadrilaterals add up to 360 degrees. So I know three of those angles out of the four. I know the 70, I know the 110, and I know the 82.5. So I can subtract them from 360 to find out what the remaining is for H. So I'll do 360 minus 70 minus 110 minus 82.5, and I'm left with 97.5 more than I require. So I know that H is 97.5 degrees, and the reason being is that it is a quadrilateral. Quadrilateral. So this was just one big question with a number of different unknown angles. Sometimes you may receive just a triangle with one known angle. You might receive a quadrilateral. But whatever it may be, hopefully this helped you. And if you have any further questions, please don't hesitate.